Embeddings and vector search is a key step when building a RAG. And that is exactly what I will show you on how to do it, on how I have done it by using Postgres, .NET, and Azure. This video is a second part of an existing video where I built the base structure of a RAG. If you want to take a look on that video, I will link it in the top, but then make sure that you get back here. So, before we start, let's go back to the theory, to the concepts, and revisit what is an embedding and why that thing is so important for what you'll be building here today. So on that previous video, we have start building our retrieval augmented generation system, okay? We have our prompt. The prompt goes to a store, finds some documents, inject the prompt and those documents into the LLM and gets the response. On that previous video, we start building the RAG, Retrieval Augmented Generation System, and the way that we are doing it is that we have a prompt. Then, based on that prompt, we are going to my blog, that is a set of static files, markdown files, and we are finding those that are related to that prompt. And then we inject both of the things, the prompt and those documents that are related, those blog posts that are related, into Azure services, Azure AI services, that is basically using OpenAI. And then we are producing a response that should be targeting the thing that I'm looking for. So this is the API that we start building. However, to build a proper RAG, a proper retrieval augmented generation, there's something here that is not perfect. There is the fact that we are basically looking into a folder, trying to find those files, but that's not efficient, okay? And the way that it's done is not that well made because it's basically looking for strict keywords, okay? It can't find, for example, related concepts. It can't find, based on the context, it can't understand that I might be looking into this, not this, okay? It's too strict. It's based on text only. And we can build something better by using embeddings. Let me explain. So we have this prompt, we go to the store, we get those related files. What we'll be working on is on this part of our system, okay? Instead of going to a store that at the moment is a folder, we'll go to a database, okay? So let me copy this and I will explain what I will be doing, what we will be doing. So our prompt will go to Postgres, basically, okay? And it's from Postgres that we'll find a set of entries that we want to send to the LLM. But how we'll be doing it? That's the thing. So the way that this will work is in the following way. We'll have our prompt. The prompt will go through an embedding model. So on our LLM, instead of using GPT 3.5 or other thing, we'll be using a specific model for embeddings. Out of it, what we'll get is a vector. So you can imagine that out of it will come something like this. So that's my vector. What is a vector? It's a set of numbers, basically. And the benefit of this process is that then when we go into the vector database, that in our case we'll be using Postgres for that. So I will try to explain this using a 2D representation of what will happen with the database, okay? Just trying to make it clear what does it mean when we are doing the vector search to find the entries that we are looking for. So imagine that this is our database. And now each circle that I will put here inside is a given document, okay? Given artifact. And you will start realizing that those are spread inside of the database, but some things work kind of like a cluster, okay? They are related, okay? There's similarity between them. So when I perform my vector search, what will basically will happen is that I will go here and I will find those concepts that are related. So I might come to the conclusion that the thing that I am looking for, we change color, is this one, okay? So I can work with distance. What does that mean? Since I have numbers, I can say I'm looking for X, and I can start looking for the distance for that concept. And some will be more related than others. So let's say that the center of this circle, this big circle that we have here, would be something like this. Okay, so naturally those two here are more related to the concept than those two, but I'm grabbing all of that. Okay, I'm taking all of that, and if I start expanding the records that I want to get based on the distance, you will notice that first I will get this one, then I will start getting that and that one, because I was expanding. Okay, I can see the distance for the concept that I'm looking for. So this is what we'll be doing. Okay, we'll use vectors inside of Postgres, and when we want to look for the concepts, we'll be using the embedding model to generate the vector to then perform the vector search. Okay, and try to find based on the distance. Also, we'll need to have something to see the data inside of that database, okay, instead of that Postgres database, and generate those embeddings as well, okay, generate that vector as well in order to have the data there, so when we search, we can find those related documents, okay? That's basically what we'll be doing. First step that we need a database, okay? For that, I created, before start recording this video, this Postgres database, Azure database for Postgres SQL flexible server, and this is the one that I will be using. Okay, I didn't create anything inside yet. Okay, I'll be doing that afterwards. And now what we can do is that we can go back into our project and let's start working on that. On our previous video, we built this method, the find relevant documents, that is looking into the directory, trying to find the words that match. And this is basically what will be changing in the process, okay? But first thing that I want to do is to create the database, okay? And see that database. So then we can come here, change the implementation of this method, and start performing that vector search. So let's start with the simple things, that is bringing here the structure of that database and a way to connect to that database, okay? As always, you can find the link in the description to grab the source code, and you can grab it for free. Okay, let's go step by step. First thing that I will do is that I will create an SQL file here where I will have the basic structure of that database. And what do I want to do there? I want to first create the extension, if not exists, the vector extension, because by default, that extension is not part of our Postgres database. That means that I couldn't use a vector type for my embedding column, okay? Then I will have my documents. The documents will have an ID, the content, for example, a description, but also the embedding, okay? The vector that I will be looking for. So I'm using this size because it's the size of those embeddings that I will be using. It depends on the model that you are using for generating them. And also I will be creating an index because we will start looking for our embedding based on the proximity, and that's the reason why I'm creating this index, so to make that search faster. Let's run this thing. If you are using Rider, you can use the option to connect to the database directly from there. Otherwise, simply connect to your Postgres database using something like pgadmin or something like that. And what I will do here is that I will run that script. And first, when I run that create extension, you will see that I will have an error, okay, which will say that it's not listed for Azure pgadmin users in Azure database for Postgres SQL. Why? There's a list of allowed extensions on Azure, and we need to go there saying that we can use this vector one. How do we do it? Go back into our Azure portal, go to server parameters that is inside of the settings. There, search for azure.extensions, go to the value and look for vector, pick that one, save it. So this will apply the permission inside of our database. Once it's finished, we can go back and run that command to create that vector extension. So let's give it a moment. Okay, it's done. So let's go back into here, run that thing again. This time it goes through. So let's run the next command. Okay, we created our database, our table, sorry. and we can create an index as well, and it's there. So if we go here into the database structure tables, we can see here the documents with all the things. Okay. Next step. Now that we have the table, I want to populate and seed it with some data. And while I'm seeding it with data, I need to generate those vectors. Okay. And because the embeddings, the vectors, is something that I don't have currently. Okay. I'm looking into the folder, and there I don't have that thing, so I need to have a way here to generate that. So let me quickly do most of the things, and you can follow along and I will explain. So let's bring a new project, and it will be a console application, and let's call it Rag with Azure Cedar. On that project, let's edit the CS proj, bring the package references for OpenAI, Entity Framework, connection to Postgres as well, and the PG vector.entity framework core package as well. And also I will add a reference to the API project. Okay, I will need some types from there. So for now, I will just do that. On our program CS, let's replace this thing with some code. So, and there what we'll do is that we'll have this configuration to read settings from app settings. Then we'll have our OpenAI client. We want to connect to OpenAI to use that embeddings model to generate our embeddings. We'll have here entity framework. Okay, we'll get this thing from the API project. We'll add it there because we'll need it there as well. And what we have here more is that we'll read the directory, go to that directory that we have configured on the other video, and then is the moment to go through the directories, try to find those index.md files, and go for each file that we have. We'll read the content, find the title, find the description, and then what we'll be doing is that we'll generate the embeddings for the content. How do we generate the embeddings? Quite simple. Let me just collapse this thing. What you'll be doing is that you'll grab the embedding client from the OpenAI client, the client to the OpenAI API, and then we'll call that to generate the embedding. Okay, one important thing here, we need to provide the embedding deployment name in the same way that in the other example that you have seen on the previous video. We have the deployment name that was something like GPT-3.5 Turbo, something like that. Here we'll have the same for the model that you are using for embeddings. We generate that embedding, we keep that embedding as an array of floats, and then it's the moment to check if we already have the document or not. So we decide if we want to update the entry that is there, or we want to create a new entry. Okay, why this thing is complaining? I still don't have that document type created. Okay, and here is basically trying to look something from the system.reflection. Just that. Then I will save and I will see the database. Okay, never run this thing. I still need to create those types, so eventually you might find some problems during the process. So let's see. What we'll do now, we'll create the application DB context. So let's go into our API. Let's add it directly there. Bring a class folder like data, create a DB context class. Okay, and now what we do is that we'll say, okay, I will have a set of documents. Okay, that will be my DB set. And when the model is created, I want to make sure that you'll be using the embedding column as a vector. Okay, with the type of vectors. So let's create a document type. So there, let's go into the models folder and create a new type. Let's call it document. I could be using this item, but let's keep it for now so I don't need to go update the existing code yet. And this way it becomes clear for you what you need to do. So I will have a class with the document, and I will use annotations just to map the things to through entity framework to the existing structure that I have. Okay. So I'll have my document with all the properties that I need and all the mappings and attributes to configure the relationship between entity framework and the existing structure. And one thing that I want to take note here is the fact that I'm using the vector type for the embedding that is part of this namespace, PG vector. How do I get that? You need this package right here, PG vector. Okay, this way I can handle it as a vector. So that means that I don't need this anymore here in theory. So let's see if it works. And on our program CS, the one that we are working on, we just need to import the thing. And when we are generating the metadata, the embeddings, we need to say this is a vector. Okay, that is done. I'm not sure if this will work. So what we'll do now is that I will configure all those settings as part of my app settings here. Sorry, not on the API, but inside of the seeder. So I need a file for the app settings.json. And there we need to work on these settings here. I will add mine, then you can add yours. But the thing that I want to take note here is about this embedding deployment name, okay? While this deployment name, the key, the endpoint is something that you can see on the previous video, how we have done it, let's try to find out what we need to do for the embeddings. So for that, let's go back into the portal, go to Azure, find your Azure AI services, go to the Foundry portal, can move to the other workspace where we're working on. And there, what I will do is that I will bring a new model. I will go here into the assets and I will deploy a base model and I will look for embeddings as well. So I'll use this text embedding 002. As always, the difference between those models might be things like the number of tokens it accepts. It might be more expensive, less expensive. So take a look into that before taking your decisions. But these type of models are specialized in generating embeddings. So that's why we are creating it. Deploying the model, that means that we can use this in our embedding deployment name. So now I will set all the other configurations and we'll try to run this thing to see if it's working. Now that is done, let's set a breakpoint just to see how it goes, run the debugger, and here we go. Notice how I have used this use vector extension to configure Postgres to recognize the vectors. And then we'll go through the directory. Okay, then eventually we start processing one of those files. And let's see what will happen once we get into the embeddings part. So here we are. We'll be using that model that we saved. And what we'll do is that we'll call that with the content, okay? All the text that is part of the content of that blog post. That will generate this array. So remember, when I do this, it goes through the model, and the model will return a set of floats that I will then convert into a vector that I will store on my database. Since I don't have it on my database, I will create it and I will add it. And eventually, let's go to the end. It will finish process every single thing and save it. If we go now into our database, drill to that table, let's run a query to check the rows. Okay, and here they are. Okay, I have 117 posts. Here's the content for all of them. No, I don't. I would say I would have some problems with description, but no, maybe I have some of them without description. And then you can see here the embeddings, okay? A vector with all of those magic numbers that we don't know when looking into it, what does it mean, okay? But we know they will be useful when we try to find related concepts. Okay, so now we can go to the next step, that is applying this into our application, okay? We came so far already. What we need to do, on the previous video, we built this method, okay? The secret will be here. Instead of going through the file system, trying to find all of this thing, we want to replace that with a different approach. What we want to do here is to go through Postgres. Okay, what do I know that I will need? I will need the embedding deployment name, embeddings deployment name, because I will be using the embedding deployment name to generate an embedding based on the prompt. We can follow the same approach that we have here, okay, and using the configuration, get that thing. I will also need the application DB context. So application DB context, Let's introduce a field for it. And now on our method, what I want to change is that instead of returning the item, I want to return the document. And inside, let's do the following. Let's have a try catch as we used to have to see if we have any problem and log that problem for now. Ideally, you shouldn't be observing this type of exceptions. Let's just do it because we are building this thing and something might go wrong. I want to set a breakpoint here. But ideally, what you would do is that it will throw here, unless it's something that you want to log and return an empty list because you couldn't find any relevant documents. Then what I will do is that I will try to get the embeddings based on the user message, based on the prompt. How do I do it? I use the same OpenAI client that I already have, use the get embedding client, provide the embedding deployment name, okay? That deployment that we created moments ago. Then inside, let me just collapse this thing. What I will do is that I will try to get the embedding response by generating the embedding async. What does it mean? I will end up with an array, okay, of floats, okay, with that vector that we have seen before. Once we have that, what I do is that I create a vector string, okay? I'm combining all the different entries of the vector, of the array into a string, okay? So I can provide it as a parameter to the next query that I will perform. I think that I could do this by sending the vector directly, but I had some problems with it, and I confess that I didn't drill down too much on that, but eventually there's a more efficient way of doing it. Just if I get that, I will let you know in the future. Once we have that, I can perform my query. How I will be doing it? I will perform a select of those documents, okay, where the embedding is not null, so I'm looking for those that have an embedding, and I will use this method, okay, this function that is the cosine distance. This is a mathematical function that will allow me to find the distance, the proximity of those embeddings. Okay, so when I provide a vector compared to the embedding vector that is inside of the database, I will try to find the ones that are closer to the one that I'm looking for. Like in that 2D matrix that I showed moments ago in the beginning of the video. And then I want this as an ascending query. Why? Because the ones that are closer will have a smaller value and the value will keep growing. And I will limit to 3 documents. So I want to keep 3 possible documents to use as an input to my rec. Okay. And then I'm providing the vector string because it's the one that I will be using here as a parameter. Based on that, I return the relevant documents on that function. Just that, okay? If I now configure on my app settings the embedding deployment name, that I will do that and run this, let's see how it goes. Okay, let me run the API. I will run it in debug mode in case something goes wrong. And something went wrong. Why? Quite simple. I forgot to configure entity framework as part of my dependency injection container. So I will register it and it should be done. So let's try again. It's running. So what we can do now is that we can try to use that HTTP client that we were using before, and let's see how it goes. So I use the same call, and it says there are several free tools available for creating diagrams, Draw.io, Lucidcharts, Creately. That is something that I don't have on my list. So let's see if it's in fact finding related things. So let's set a breakpoint here to find the relevant documents, perform the same HTTP request, and you can see it doesn't stop on that breakpoint. So that's the reason why I'm getting results that are not the ones that I'm looking for. If I go to the debug window, you can see that there wasn't one exception. Why? We have that try catch there. And notice that we have a problem regarding the vector, okay? So likely what is happening is that here, when I'm finding the relevant things, basically I can't deserialize to that type. And why do we have that vector error? Because when we registered our DB context on our API, we forgot about one thing. we need to provide in the options to use the vector, okay? Otherwise, this thing will not work. So with that, it will have all the converters needed, so we can run the API. Let's run the debugger once again, and let's see if now we stop on that breakpoint. So let's run the same request, and here we are. We found out 3 possible documents, okay? And you can see that the closest one, so the first, is this discover the top 10 architecture diagrams, blah, blah, blah. That, if you go to my blog, should be based on this blog post. And if we go here, grab the title, search it, you can see it matches. And now, based on that, what we'll see is that once we have our response of the LLM, because now we'll use that as an input combined with the prompt, so we'll have our reg, we can see that, sorry, let's run again the request timeout. We can see that now the answer will be more based on my blog post. So it will recommend diagrams.net, draw.io, xcalidraw, PlantUML, Mermaid. So it's based on that answer. But this becomes even more interesting when we use one of the other requests that we have, like, for example, this one that if you have watched the previous video, you know that the answer was not that good, but now look what happens. So if we open here the answer, it will say, yes, you have a detailed information on applying the result pattern in C#. It mentions the article. So if we go here and let me go to all the blog posts, it's finding this one and saying that the article explains how to implement the result pattern in C#. If you have watched the previous video, you know that to this answer, there was nothing specific that it could point out, okay? So it was not that effective because we were looking for keywords inside of a folder, and we were not finding that this one was the more related article that I have to that question. By using embeddings, going through that model that is generating the embeddings, storing it as part of my Postgres database, things become more efficient. I give better answers, and this way I can build a proper retrieval augmented generation system. Okay, this way I'm in fact improving the possible answers that I will get out of my LLM. This is it. Okay, you can grab the source code in the link in the description. I was thinking that eventually it might be a good idea to show you how I would build my first UI on top of this API. If you think that is interesting, please let me know in the comments and make sure you subscribe in case I do that, so you can be notified once I release such a video. Let me know what you think. If you would do this thing differently, I'm still learning, okay? This is based on my experience. So if you have something to teach me, please let me know. I would love to know. Please leave a comment, subscribe, let me know what you think, and I will see you in the next one.